Okay, let us see the first example in the Pulley system is here. A taut string fixed at one end passes over a movable pulley of mass 2 kilograms and over a fixed pulley and carries a particle of 6 mass on the other end. Find the acceleration of the movable pulley, acceleration of the 6 kilogram particle, and tension in the string. So here they are not giving anything like a diagram, so you sketch it yourself. Let us go through the sketching together. So you start by drawing a ground where you are going to attach one which is fixed. So the idea of drawing one fixed at one end, end is fixed, so this is going to be our string. This is how you sketch. It is. You sketch like this. Then to pass over a movable string, a movable pulley. Then after it will come, it will pass over a fixed pulley. Then it will go down. That's how the sketch will is. Then after you put the pulleys. This is the movable one, and then this one is going to be the one which is fixed there. And this is going to be that one is fixed. And the sketch is done. As simple as that. So this one, they're telling us that the string under a movable pulley of, so this is the movable, so it has 2 kilograms. And over a fixed which carries at the other end. So here, this one is carrying 6 kilograms. 6 kilograms. So that would be the sketch. So the question would be like that if they sketch for you. If they don't, the string is fixed here. At the other end is touching or is having a 6 kilogram mass. As simple as that. And the sketch is done. Okay, that's starting with the. Okay, find the acceleration. Of course, it's touching this string is going to be having tension in it, and the tension is going to be the same now because it's the same string. Even here it's going to be having T, then here T. Of course, even here it's going to be having T, then T also there. Of course, because these ones are having mass, we are going to have a weight like this. This is going to be 2G. This one which is not fixed, what we call the movable. This one is fixed, so it's not moving, but this one is moving as it depends on where this one is accelerating. Okay, so this one is called the 6G weight. To get the weight, we get the mass, times the gravitational, like that. So now from there, we know that you check, this one is a movable, it's between the two portions of the string, as we say. We said if this one is going to be moving like this, because this weight is going to pull, that means that this one, as it moves, this one is going to be moving up. So here the acceleration of this one is going to be in this direction, and then that's call it A. If the acceleration of this one between the string is A, then the acceleration of this particle at the end of the string for it is twice this A. And so because it's moving down, that's why the acceleration is in that direction. As you pull this one down, this one is going to be pushed up. That's why this one is moving up, and this one is moving down. So we say the acceleration at the end of the particle is twice the acceleration of the particle between the two portions of the string. This is the string, this one is between. So this one is always, the acceleration here, to get this one is always a half of what is here. Or this one is twice this, as simple as that. After doing that, the rest are very easy. So, because we come and then we see the forces at the 2 kilogram mass. So it's not the acceleration there is acting in this direction. You know that always our resultant force is equal to the mass times the acceleration is in Newton per second law. So what is this one is going up. So based on this mass now, so what is pulling it up? We have this and this. So we have first of all T plus T. Is there anything which is pulling it down that is opposing? Yes, this one. So we subtract minus 2G will be equal to the mass 2 times the acceleration. Because here the acceleration is A. That's why here I'm having A. So it's like this one will be 2T, which you can easily divide through, but people will get lost. That's why I'm having now is that I can just divide through by 2, T minus G equaling to A, and I call this equation 1. When now we come to the 6 kilogram mass, Now, start this one now, and this one, the acceleration in this direction, you always be careful the direction of the acceleration. So now here, the acceleration is in that direction, 2a. So that always our resultant force will be equal to m times a. Now what's the result? What's pushing it down? So this direction is, this is the force that is pulling it down. Is there anything opposing? Yes, there is this one opposing. It's equal to the mass, which is 6. Now the acceleration here is 2a. That's why when you pass that, the rest are very easy. So simplifying, so this one will be 6g minus t equaling to 12a. And I call this equation 2. They want us to get acceleration of the moving. So what are you going to do so that we can easily add this and this? So 1 plus 2, okay, 1 plus 2. What do you have if we add the 2? So here I have t minus d equaling to n. Then here I start with the t, and I will start with this t. So this would be negative plus now 6g equaling to 12a. So then we add these 2. We add those 2. This plus this will get 0. This plus this will get 5. This 5g equaling to 13a. So that our a is going to be 5g over 13, which we can every substitute our. Okay, if you want, you can substitute our a. Remember, they want us to get a at Pulley a. At movable Pulley, this one. So the acceleration is that. So we get 5 into 9.8 over 13. And acceleration there, give it there. In meters per second. Now, this is part A. Then at B, remember at our B, so part B, the acceleration of the seismic. So that acceleration here will be 2a. Acceleration will be 2a, which will be 2 into our a, which is 5 b over 13. So this will be 10 into 9.8 over 13, which you can every is going to be 98 over 13 meters per second squared. Acceleration at 6 kg. We say this right this. Okay. You see that this one you can every write it as 49. It's regarding. So let me write 49 over 13. Okay. I'm going to have it as 49 over 13 meters per second. Then you did it like that. So we have the acceleration both at this and then also at that. The tension in the spring, part C. Our tension, you come from which one is easy? This one is easier. So you say from 1, or is this one is very easy. So T is going to be A plus B. When I take this side becomes a positive. So my A, which is here 5B over 13, then plus this B. Because for 5 makes 13 plus 5, that will be 18 B over 13. So our tension will be 18 into 9.8 over 13. Okay, and then this will give us this will give us 176.4 over 13, and these are in newtons, which you can give for the small places, and you indicate that you are giving an answer for the small places. So that's how we handle. Pulleys are very easy. Once you know that this pulley between the two portions of the string, its acceleration is going to be a half the acceleration of the particle at the end of the string. Once you know that, life is very easy. So the overall acceleration is this one. We have only two particles. I mean two pulleys. So the overall is going to be this. So this one is going to be a half of the overall, which you well.